Okay, so when you write the standard form, you need to know the center of the circle and you need to know the radius of the circle.
Okay.
So I'm going to put capital C. That's how they usually name the center, which is a set of coordinates, and then the radius. So for number 1, what's the center?
0, 0.
Yeah. Well, I'm right over here. Sorry. 0, 0. And the radius would be how much?
6.
Yeah. So then the format for the equation of a circle is always x minus, I do x sub 1, but I think they use an h, but it's the same idea.
Okay.
Y minus y squared equals the radius squared. So you plug in the information that you found from the graph into the equation. So when your center's at the origin, 0, 0, something happens to the equation that's just a common thing that keeps happening. So when your center's at the origin, it kind of saves you time, but I want you to see why.
What?
So if you put your zeros in those places for the x1 and y1,
Okay.
in the first parentheses, you'd have x minus 0, which is how much?
0.
X minus 0.
X.
Yeah, there you go. The other way around. So in the first part, you just have x and it's squared. Sorry. Okay. Plus, in the second parentheses, the same thing happens. Same thing happens. Y minus 0 is just y. So it's y squared.
Okay.
So every time your origin is at 0, 0. Sorry, I keep saying it backwards. Every time your center is at the origin, or the 0, 0 is your center, then the left side of your equation is just going to look like that, x squared plus y squared.
Okay.
And then you square your radius, which for this question would be 6 squared, 36.
And then you just leave it like that?
Yes, because you're just writing an equation. Just like when you were doing lines, you might have like y equals 3x plus 4 or something, and you left it like that. You left the y and the x in there. It's the same idea, but for circles instead of lines.
Okay.
If your origin is somewhere different, like either 3 or 4, I keep saying origin. If your center is not the origin, then you plug into the formula. So let's do one of those. Do you want to do 3 or 4?
It doesn't matter.
Okay, 3's first, so we'll do 3. For number 3, what's the center of that circle?
1, 1.
Mm-hmm. And the radius?
The radius would just be 1.
Yeah. Okay, so you need those same pieces of information, and you need the same starting equation over here. But this time you're going to take that center and you're going to plug it in, and it won't make everything in that parentheses equal x. So it'll be x minus 1 squared plus y minus your other 1 squared equals your radius squared, which for number 3 is 1 squared. So it's just 1 out there. Lots of 1s in this question.
Okay.
Because x minus 1, we don't know how much it is. If we don't know what x is, you just leave it like this. That is your final equation for number 3. Does that make sense?
Yes, that makes sense.
Okay. So when your center's at the origin, it's just the left side always looks like that. But if it's not at the origin, it's going to still have the parentheses in there.
Okay. Thank you.
You're welcome.
Mom.
Okay, Rachel.
Mom.
What from 10.6?
So there was a couple, but I think my main one was number 14 on page 685.
Okay, let me get that on the screen. 14, 685.
Get red card. That red card.
It's getting there. It takes a minute.
Decides to take the frog to a place where it'll feel safer.
Maybe, possibly. All right, can you see it now?
It's just black. Oh, now I can see it, yeah.
Okay, sorry, there's a delay.
Yeah,
I think my computer's tired. So 14, you have 2 secants in that one because they each touch the circle twice and keep going, and they meet at this common external point. So that goes with the theorem that says if you have 2 secants with a common external point. I forgot which number starts that way, but if that's the case, then when it's a secant, you do the whole thing times the outside. The secant segment times the external segment equals the secant segment times the external segment. Basically, the whole thing times the outside. So for 14, the top secant, what would you multiply?
You do x times x plus 45, right?
Not for this one. This one's different, the way they've labeled it. 45 is actually the whole thing.
The whole thing equals 45.
Yeah.
Let's see if I was doing that before. Oh, okay. So it's going to be x times 45.
You got it. If 45 was just this piece right here, then what you said before was right.
Okay.
But since it's the whole thing, it is this. And then the bottom secant, what would you multiply?
It would be 27 times 50.
Yes, because 50 is the whole thing on the bottom.
40. Yeah, is that right?
Mm-hmm. So 45 times x equals 27 times 50.
So
13.
that would equal 30.
Yes, when you divide, you are correct.
Okay, I can't hear anything, just so you know. So I don't know if it's like broken. I don't know if you can hear me, but the audio is not working.
Uh-oh. Let's see. Can you hear me now?
Okay. Oh, and then I have one other one. Number 11. That was really hard too for me. Oh, it's okay. Okay, cool.
Whoa. Why can we go upstairs?
You going upstairs?
Yeah.
Why are you going upstairs?
He said the Lego man's going
You want to play
upstairs.
Legos? You want to go play Legos?
Nobody's gonna hit a foot.
Let's see what you got. Let's see what you got. Okay, so what you got there, that's okay. I don't want you to get that nails. You hear me? I don't want you to get that nails in your way. Well, why did you check her mouth out, Tina?
Mm-mm.
She said, I got some teeth. I'll show you what I can do if you stick your finger in it. You get up there.
Yoga man.
It's so quiet.
Yoga man. Yoga man. Yoga man. No. It's a yoga man. Yoga man.
I got here. You see, I get from the church. Hello? Hello?
Yeah, that looks good.
Okay.
That's what I got. I just can't solve from here.
Yeah.
You can hear me still. Yes, ma'am. That's good.
Managed to float either. Never mind, friends.
Okay, thank you. I understand now. What I was doing wrong was I wasn't foiling the x plus 4 squared. So that's what was wrong. But thank you. I understand now.
Alex and Anna, can y'all hear me?
Yes, I can hear you.
Okay. Do y'all have other questions?
If Alex doesn't have any, number 12.
Okay, on practice B.
Yes.
Okay.
Mom, I see a table.
Be careful, Cruz.
Mama,
I see you.
a table.
I see you sitting on the table. Be careful. All right. So if you're going to write the equation in standard form, this is the standard form. Oh, sorry. standard form is the x minus x. X minus. Like I said, I think y'all's worksheet shows you an H there, but I use the little x1 because it reminds you that you're plugging in your x value right there.
Okay.
It's r squared. Excuse me. Okay, so for number 12, if the center 0, 0, do you remember what the left side of our equation is going to look like if it's 0, 0?
Yes. X squared plus y squared.
You got it. And then it tells you, a point on the circle. So we don't know the radius. In order to find the radius, if you think about a circle, if we know the center is 0, 0, and we know this other point, I'm just going to pick a spot, let's say is 3, -4. What do we call that length between the center and that point?
The radius.
The radius. So if we can find how long it is from that point to the center of the circle, then we'll know the radius of the circle.
Okay, so you just do distance formula?
Yes, exactly. So I don't know if I'll have room over here. I'll see how tiny I can write. The x minus what?
X minus.
Oh, not x. I'm so sorry. It'd be what minus what? I'm thinking use your x's.
Oh, would it be 3 minus 0?
Mm-hmm.
And then squared. And then plus -4 minus 0 squared.
You got it. Oh, not comma. All right. So 3 minus 0 is 3. Square it, and you get
9.
9 plus -4 minus 0 is -4. Square it.
16.
Mm-hmm. You still have your big square root. Underneath, that's 25. So what's the radius?
5.
You got it. So then to plug it into the equation, you need to square it. So it'd be x squared plus y squared equals 25.
Okay.
So if they don't tell you the radius, you have to find the radius using distance.
Okay, thank you.
You're welcome. Alex, do you have a question?
Yeah. So numbers 17 through 20, just like any one of those, how exactly do I find the diameter? Because it doesn't really explain that much in the study guide.
Yeah, it taught more about the radius. Let's see. Let me get one of those. I'm not really sure what this show is that my little guy's watching. Sorry about the weird noise in the back.
That's all right.
Odd cartoon. Okay, so if you're finding the diameter, you can find the radius pretty easy if it is a standard form of a circle equation, which if you look at all these, they are in the standard form. Number 17, that would be a circle if it centers at the origin 0, 0. And all the other ones, because it's an x minus a number squared, y minus a number squared, and a plus sign in the middle, those are all equations for circles in standard form. So if it's in standard form, this last number is the radius squared. So like number 17, what would the radius of that circle be?
10.
10. So if 10 is the radius, what's the diameter?
Then the diameter would be 20.
You got it. Does that make sense? Excuse me.
So like the stuff on the left of the equal sign, so does that really matter in the sense of this, or is it mainly just you take the square root of whatever is on the right hand side and then double that?
You are correct. The left hand is just telling you about where the center of the circle is. The right hand is telling you about the radius, which can tell you
that
about the
makes
diameter.
sense.
Yeah.
So, like, for instance, that would make 19. Wait, 19 would be 4. So
19 would be what? It was just a little bit quiet. Christian, what'd you say?
4? Would 19 still be 4 in that case?
Yeah, because the radius would be the square root of that is 2. And then the diameter, if you double it, would be 4.
That makes sense.
Good. Other questions?
For a number like, I guess just kind of like 23 through 26, that I just plug in the x and the y, correct?
Let me look back at them. 23, 26. Yes, you plug in the x for the x value, the y for the y, and see if it makes that equation true. So whatever you get on the left side, does it equal 100?
Okay, that makes sense. This is what I thought I was supposed to do, but I wasn't sure because I was like, that seems too simple.
It does, doesn't it? That's what I was telling y'all. Some in the past years, people see that first worksheet and they're like, "Oh my goodness, this looks so hard." But then when they start doing it, they're like, "Is it really this easy?" Yep, just plugging in. All right, other questions?
If anyone else has any, they can ask, but I think 28 I was a little confused on.
Okay, let's see. 28.
Yeah, same for me.
All right. Come on, computer. While I'm getting it, we did a few years ago a thing in the yearbook about people who do sports outside of school because it was the year of the Olympics, and we wanted to put the Olympic flag in the yearbook to like be able to remember that that was the year that the Olympics and stuff. And it was such a big deal. We had to get all this special permission. I had to contact the Olympic Committee and get special permission that we weren't selling or trying to make money from the Olympic flag. It's funny. But if you'll notice, it's in the yearbook from a few years ago. All right, let's see. All right, so you're going to design this flag. The distance between any two adjacent rings in the same row is 3 inches. So what that's saying is, make it a little bit bigger. Maybe that'll help. Can y'all see the problem?
Yeah.
Okay. Yeah, okay. Just want to make sure it was showing on the screen. So it means that this little distance in here between those in the same row, so all those green little pieces, each of those is 3 inches.
Okay.
And then, yeah, okay, so everything else is labeled. So for part A, use the given dimensions to write equations representing the outer circles of the 5 rings. Use inches as units in a coordinate plane with the lower left corner of the flag as the origin. So here's the origin. You're thinking of this like a coordinate plane where this is 0, 0. And it wants us to write equations of each of these circles. So you have to figure out where the center of each circle would be on the coordinate plane. Does that make sense?
Yeah.
Okay.
Yes.
So I'm just going to go with the top left one because it's the furthest to the left. So it says we go out 15 inches. So think of like 15 spaces on the X value. And then we don't know how far we're going into the circle. So we need to know the radius of the circle. Do you see any of the information they give us that could help us find the radius of the circles?
The 26 inches, because if you divide that in half, because the 26 is the diameter, so the radius has to be 13.
Perfect. You're right. Do y'all see that?
Yes.
That's exactly right. That's the piece of information that had to help you get the radius. So now that we know the radius, we go 15 spaces to get to the circle. And then we're going to go 13 more spaces to get to the center of that circle. You with me?
Yes.
So this, on the X value, we came out 15 and we went 13 more. This is 28 because 15 plus 13. Does that make sense?
Yes.
Okay, so we know the center of this first circle is going to be 28 something. So now we need to figure out the Y value of it. So kind of the same process, but this time up from the bottom. So we could do the 18 and then 13 again, but they also give us this 31 over here that shows that's how you get to that second row of circles, the highest row of circles. So we know we're coming up just to get to the circle. We went 31 spaces up. And then to get to the center of the circle, we had to go 13 more. So it would be, what was that, 31 plus 13, 44?
Mommy, sit a chair.
Yeah, I see you.
Mommy, sit a chair.
You are sitting in the chair. So the center of the top left circle would be 28 and then a Y value 44.
Okay.
Make sense?
Yes.
All right. So then you use we can go ahead and write the equation for that first circle because we have the standard. I'll write it over here in this little spot. X minus x1 squared plus y minus y1 squared equals radius squared. So we can plug in now because we have a center and we know the radius. So what would the equation for the top left circle be?
X minus 28 squared plus y minus 44 squared equals 13.
Squared.
Mommy, sit the whole one.
I see that, bud. It'd be 13 squared, which is,
169.
yes.
Mommy, see the picture.
I do see that pencil.
Mom,
Does that make sense?
Mom, I think
Yeah.
well.
Yeah. Okay. All right. I'm gonna get a different color and we'll work on the next one. Do you want to work on the one to the right of it or the one kind of below it?
I guess the one kind of below it.
Okay. You got to do both, so it just depends on which one you want to do first.
Oh, okay.
All right. So for the X value, because we need to now find, I see, buddy. We need to find this center. So we came out. Okay, buddy. Okay. Goodness gracious, he is persistent. We came out 15. And then we got to the center of that circle. So that was 28, the top one. And then if we kept going, that would be 13 more. Let's see, the whole thing. I'm trying to figure it out too. I'm working through it. Let's see. Whole thing is 26. 18, the edge. 13. I'm trying to figure out if the light gray one there that I'm working on, if it actually touches the center, if it would line up here.
Okay.
I'm trying to see if there's enough information to assume that. I don't want to assume. Let's see. That's 31.
I think it would, because I think if you add 18 and 13, it's 31. So I think it lines up.
Yeah, that makes sense that this is 13. All right, so I'm going to say that we're on the x value, we're at 28 at the edge of the circle. So then we need to go 13 more to get to the middle, to be here. So this space, are y'all following it all? This space right there needs to be 13 more, slightly.
Yeah,
Yeah.
that makes sense.
So 28 plus 13 is 41. I don't know, buddy. 41. And then the value on the y is 31. So that's center. It's 41, 31. And we know the radius is going to stay the same. So what would the equation for that circle be?
Wait. No, is it like that?
What's that?
Oh, wait. I was looking at the green one. Sorry.
Oh, okay. Sorry, I'm trying to switch up colors because it's going to get messy. So I'm going to do each circle in a different color to write with. So it'd be x minus the x value. Oh boy, what happened there? Sorry. Get out of there. Okay. X minus 41. Y minus 31. And that will equal 169 because the radius stays the same.
Okay.
All right, I'm going to do this one now where I just made a red center. What would be the center of that circle? The top middle.
Top.
Uh-oh, is he making a fuss this time about nothing? He really can't.
40. Wait, no. 57?
Let's see, 41 plus 40, 28 plus 13 is 41 plus 1.5 plus 13. I think these are going to become half because of that 3 in between.
Okay.
It'll be.
So if this falls in the middle of that, what'd you say?
It looks like it'll split the 3 in half from rather than aligning again, because they have to be, each one has to be a uniform length apart, rather than, because the top two are 3 inches apart, you don't want your bottom circles to lean one way or the other. You want them to be directly centered. So I'd assume that it would be 1.5 plus your diameters.
Yeah, that's why I'm doubting. I'm thinking we might be off on this purple one. Maybe we should just tell them that the Olympic rings are a done deal. Just go with what they've already figured out, right?
Y'all already did the math.
Don't reinvent your rings. Just go with what you got.
We don't need to redo math that's already been done, right?
All right, let me double check this before we get too off. So I'm thinking that the 1.5. I'm getting 1.5 because the green 3 space in between, I'm thinking it's got to be 1.5 on each side of that. So whatever the X value is for this radius, we're going to have to add 1.5 to it, plus 13 to get us into that center. So 14.5 is going to have to be this space. But I want to make sure we're adding 14.5 to the right number. We might have the X value wrong in the other. Let me just look. How about that? Get out of there. So y'all are going to see the answer key, but just, you know, let's see. I don't even know what number we're working on. 28. Yep, they're adding in the half already. So 42.5. Let's go back to that one. All right, here's why it's 42.5 instead of this 41. Because I forgot about the 3. If you've got this 3 that's green in between right here, when you get to the radius of the equation we just wrote, to get to that center from the radius, you're going to have 13, but then in between there, you have 1.5 extra to add to it. So instead of 41, it's going to be 42.5. Did y'all follow that at all? Or do I need to think of another way to explain it?
It makes sense to me.
Anna?
I sort of got it. I'm a little bit lost.
That's okay. Let me go back. I'll try to say it a different way. Okay. So the first circle, the green, are you good with that?
Yes.
Yeah.
So then the purplish color, what we're doing with that one is we got to figure out where the center of it is, because anytime you write these equations, you have to have the center and the radius. Radius, we're good to go with every circle, but the center is going to change depending on where it is.
Okay.
So we know that up in the instructions, it told us that there's 3 inches between them. That's what the little very first thing I wrote, and I just erased. But between them is 3. So between these circles right here, this space that I'm coloring is 3.
Okay.
So instead of just going from the green circle center and adding 13, that would get you to the edge of that circle. But the red, purplish, whatever color that is, this purplish center is not exactly touching the end of this circle because there's 3 in between. Okay. And so it's right in the middle of that 3 in between. So the space there is 1.5.
Now I get it.
Yeah. Alex, are you still there? Does that make sense to you?
Yeah. Because you had to divide the 3 in half because that's where, yeah.
You got it. So because of that, in this equation that was down here in this purplish color, we need to change the X value. Instead of 41, it needs to be 42.5 because we're adding 1.5 to it.
Is that all we need to change necessarily?
Yes.
Awesome.
Okay, so then, be careful, Chris. So then, back to our red center. The top middle. This one's going to be easier now that we figured out the 1.5 deal, okay? So, the purple took 1.5 of that. To get to this red center circle, we've got another 1.5. The other half of that, this little red area here. So the purple circle, the center was at 42.5. We're going to add 1.5 to that so that we'll get to the middle circle. So now we're at the edge of the middle circle. Then we're going to add 13 to that because we're doing a radius to get to the center. Are y'all with me?
Yes.
Yeah.
let's see.
So we're just continually
44
adding.
plus 13, 57. What'd you say?
So we're just adding 13 and a half to everyone. Or 14 and a half.
14 and a half, yes. For the top circles, and then to get from the two bottom one to the other, we'll do the same. So the red center, we're at the same height, so the y value is going to stay the same. Still going to be 44.
Mm-hmm.
The x value is going to be 57 because we did 42 and a half plus 1 and a half plus 13. That is a helicopter. I like it.
So, wow, this is looking easier than I thought it was. So essentially, we just need to keep rewriting the equation, change the y value, and add 13 and a half every time.
Yes.
Okay.
So the red circle, you plug in that center. $44. And you still have 169 because the radius stays the same. Do y'all want to keep going, or would you like to try the last two and then check them after you try them?
I'll try them and check them personally.
Yeah.
I can mute it if y'all want to.
Yeah, I'll do this one.
Okay, y'all try them, and then you can check them after you try them. I might keep working. I'll mute mine, and I'll keep working so that you can check them on the screen once you get them done. Unless, is there another problem y'all want to work before you do that, or do you want to go with that one right now?
I kind of want to get this one done while Math Lab's still going because this one looks so like there's room to mess up.
All right. Y'all keep going with this one. I'll mute it. He finds the loudest toy possible. I'll mute it and finish. Y'all finish this one, and then you check, okay?
Okay.
Okay.
All right. Are y'all still working?
No, ma'am.
Now you got it?
Yes.
Does it match my messy writing?
Yep.
Yeah. Good. That one was tricky. That extra 1.5 thing threw me for a loop a little bit too, so I get it. The process though, once we got that 1.5 taken care of, did the rest of it seem okay or still really tricky?
That seemed okay.
Yeah.
Yeah, it's okay.
All right. Part B is asking about, it says, each ring is 3 inches thick. How can you adjust the equations of the outer circles to write the equations representing the inner circles? So what we were doing, stop, Cruz. We were doing from the center to the outside edge is all those equations we wrote. So if, I don't even know what other color I can choose. We use too many colors. We use neon green. If we know that this circle is 3 inches wide and we did the outside, then the side, how would that change the equation for the inside circle?
Would it just reverse it?
What do you mean?
I don't know. I don't know.
It's okay. Would it change the center of the circle? No, right? Because it's not moving it around. So the center wouldn't change. I mean, if they said, hey, if you moved it to the left or something, okay, then we'd have a new center if our circle came over here. But if we're leaving it where it is, we're just making it smaller. What changes?
The radius.
The radius, yeah. So if, let me use this space because it's so messy up there. So if we took off these 3 inches, we'd have a smaller radius. What would our new radius be?
10.
10, yeah. So in our equations, that would change this part of the equation. 169, what would it be?
100.
Yeah. It'd be r squared equals 100. So it would just, the center wouldn't change because you didn't move the circle somewhere different. All you did was make a smaller circle, which means the radius would be smaller. Are we all on the same page with that one? Y'all feel okay about that?
Yes, ma'am.
Yeah. Christian and Anna, y'all feel okay with that one?
Yeah. Yeah. I realized what I did instead of adding 13.5, or instead of adding 14.5, I was adding 13.5.
Oh, gotcha.
So I redid them all. But then I got it.
Gotcha.
That was surprisingly complicated. They put that much work into it.
Yeah, like I said, without that 1.5 thrown in there, it wouldn't have been so bad. If you just knew that they like met up with each other, then you just keep using 13. But that extra 1.5 kind of made it more tricky.
Yeah, I agree.
Do y'all have other questions from this assignment or the lesson or something before it?
No questions yet, but I'm kind of working backwards because I started on number 28 is when I kind of joined. So
Okay.
I figured might as well while I have it.
Okay. All right, I'm going to go back to 23 and 26 because Garrett didn't see those earlier. I think we did them a minute ago, but let me get back to that. Let's see. Oh, yeah. I remember now. All right, Garrett, can you hear me? Yes. Okay. It's coming up. It just takes it a minute to load. All right, 23 through 26. You're kind of testing those points to see if they're on the circle. And the way you do that is by plugging in those points to the equation that they gave you to see if it makes it true. So, for instance, number 23, hang on, let me get some room so I can write that one. For number 23, you would say 0, you'd plug in for x, and you'd plug in the 0 for y. So you'd have parentheses 0 minus 3 squared plus parentheses 0 minus 8 squared. And you're trying to see, does it equal 100? Does that work out? So it'd be negative 3 squared. This parentheses will give you 9. Negative 8 squared. That parentheses will give you 64. 64 and 9 is just 73, so it's not equal. So you'd say that it's not on the circle.
Okay, thank you.
You're welcome. Does that make sense?
Yeah, it does.
Yeah? Okay, good. You just test them all with that one equation they gave you.
But I do need more clarification on the other ones.
No, you were good on the others?
No, I need more help on those.
I'm sorry, I missed what you said.
I said I need more help on those.
Okay. Which ones?
24 to 26.
Oh, sorry. I did the wrong one. I didn't realize. Let's see. We're going to erase and so we can see those. All right. So you're going to plug in these coordinates to that same equation. You're going to plug in the 13 for x, the 8 for y. So for 24, it would be 13 minus 3 squared plus y. Oh, not y. Sorry. I forgot I was plugging something in. 8. Yeah, there you go. 8 minus 8 squared equals 100. Well, does it equal 100 is our question. So the first parentheses, you would get 10 squared 100 plus, that'd be 0 squared, which is a 0. And hey, look at that. 100 does equal 100. So that one would be yes.
Okay, I think I got it now.
Yeah?
Yeah, I think I'm good.
Okay. Good.
Okay.
You're welcome. Other questions, anybody?
I'm a little confused on number 27.
27? All right. Let's see. Come on.
Sorry, I have to go outside.
It's all right. Okay.
Let's see. Let's get you. What you got? Okay. Let's see. What you got? You gotta come here and see ya, baby. You gotta come here and see ya, baby. Oh, good gracious.
Okay. So let's see. Coordinates are miles. So it's telling you determine by each of the size of graphs what are the coordinates epicenter. So what you can do with these is use the point is telling you, let's see, 3 locations, the epicenter. I would use these as the center and then the miles as the radius, because here's my thought process. Let's just say here's a point where you feel the earthquake. and it says that the epicenter is 5 miles away. It could be 5 miles this way or this way or this way or this way. You know, it could go different directions. So you're not sure which direction it's going. So if you make the point they give you as the center, I think that'll be the best way to go about it. Does that make sense?
Yeah.
Okay. So 2, 1, and it's counting by 2s on this graph. I'm going to make it bigger. There we go. All right. 2, 1, and then 5 miles. So 5 miles in every direction. 4, 6. 5, 2, 4, 5. This is going to be so messy. There's my beautiful circle. Then the second one, -2, -2. And 6 miles. 2, 4, 6. 2, 4, 6. 2, 4, 6. 2, 4, 6. All right. When you're graphing these, I think I told y'all in class, but just show me that you're doing these points like I did here, because then even if your circle's messy, I know that you were using the right strategy to graph. Oof, that one got really rough. And then -6, 4. So 2, 4, 6. 4. 4 miles. 2, 4. 2, 4. 2, 4. 2, 4. All right.
Like you had a hard time.
What are the coordinates of the epicenter? Where do all 3 circles collide?
-2, 4.
Seems like it, yes. Right here. And then people could feel the earthquake for up to 9 miles from its epicenter. Could a person at 4, -5 feel it? So let's see. 4, -5 would be 2, 4. Up to 9 miles from the epicenter. So how could you tell if they could feel it or not?
Distance formula?
Yeah, there you go. You do the distance from here to here. And this is 4, -5. And that was -2, 4. So let's see. 4 or -2 minus 4. Sorry, my minus sign did crazy. -2 minus 4 and 4 minus -5. -6 squared. Is that plus 9 squared? Seven. 117. Root 117. I don't know what it is, but I know it's more than 9 because the square root of 81 is 9. So could a person at that point feel it?
No.
No, don't think so.
So it says to explain that. It's just me showing my work enough to explain that? Or did you want me to like write out what I did?
Just showing your work is fine. You could say that root 17 is more than 9. You could do that. Or you could say, no, it's too far away or something. But if I saw where you were finding that distance, that tells me you were going about it the right way.
Okay.
Not just, you wouldn't get credit if you just randomly guess yes or no. I mean, you got a 50-50 shot, but
It looks like it's more than 9, so we're going to say yes.
right. Which in this case happens to work, but it wouldn't always. So, especially with my very messy circles, it wouldn't always be. Other questions? What, Christian?
Can we run over number 16?
16?
1, 6.
Sorry, it's quiet. I'm trying to hear you, but my house is not silent. And your microphone seems kind of quiet.
Here. Wait, no, that's not one.
Let's see.
Here, Mommy.
Thank you, Cruz.
Zoe, what are you doing?
All right, you said 16, correct? Okay, 16. Let me get rid of this below it.
Can you hear me a little better?
A little better, yeah.
Okay.
It sounds kind of like when somebody's talking on the phone and they kind of cover up the mouthpiece a little bit. That's kind of what it sounds like. Okay. So if you know the center of a circle and you know a point on the circle, that's not enough to write an equation, because to write an equation, you have to have a center and you have to have a radius. So how could you find the radius with the information that it tells you here?
Distance formula. Right?
What was that?
Distance formula.
You got it, distance formula. Because if you have your circle and your center to a point on that circle is always going to be the radius. So it'd be just using these numbers, 17 minus -3 and 24 minus 9. So 20 squared. And what is that? 15 squared.
Yeah.
Do you know the square root of 625?
Not off the top of my head.
It is 25, I believe. I think it is.
I'll check your math.
I might be wrong. It's very possible.
625. 25.
Boom. There we go. All right. So 25 is your radius. So now you've got your center and your radius. Then you put it in the formula.
17 not plus 17 minus 17. Plus y minus 24. 23 squared equals. Wait a minute, that would just be 625 again, right?
You're right.
So many roots.
All right. Well, if y'all have more questions, you can email. And I will check my email in just a little while after I get back from getting my guys at school. But hope y'all have a good day.
You too.
Thank
Bye,
you.
thank you.
You're welcome.
That's a